Hello everyone. Today we are going to solve this question. It's on codeforces. It's a div to D problem. So, you first of all you can try this question out. And the question says that we have a W into H size of chocolate bar. Okay, and the coordinate system is like a Cartesian plane. We have point 0, 0 as origin. Okay, and it is at lower left corner of the bar, and the point W comma H, it is upper right corner. Okay, now what we have to do, Bob will decide to split the bar into pieces by breaking it. Okay, each break is a segment parallel to one of the coordinate axes. So it will be like if we have a bar, whatever cut we are going to make, it will be like either horizontal or vertical. And after Bob breaks some part into two parts, he breaks the resulting parts separately and independently from each other. Like if I have a bar of 2 by 2 and from middle I made a vertical cut. So I'll have two pieces of size 2. Okay. So after breaking whatever resulting parts are there, which are separated from each other, he'll completely separate it out. Okay. Also, he doesn't move the parts of the bar. And Bob made n breaks and wrote them down in his notebook in arbitrary order. At the end, he got n plus 1 parts. Now he wants to calculate their areas and we have to help him. Okay. And output of n plus 1 numbers, areas of the resulting part is in increasing order. Like we have to print in increasing order. What we'll do? We'll first take this example. Okay. So I have 2 by 2 chocolate piece. Now, uh, what cut we have? 1012, 1012, and 011, 0111. So, see, I have this box, no, not box, chocolate bar. Okay, this is our 0, comma 0. This will, okay, this will 1, comma 0, 2, comma 0. This will be 0, comma 1 and 0, comma 2. So from 1, comma 0, this place to to uh, 1, comma 2. 1, comma 2 will be here. 1, comma 2. We are going to make a break. So we'll break from here. After that 0, 1 to 1, 1. So this is 0, 1 and this is 1, 1. So this will be another cut. So this is our first part, this is our second part, this is our third part. Okay, and according to area, the output will be 1, comma 1, comma 2 because this one is bigger. It has two area. See, output is 1, 1, 2. Now we'll take this example 2 by 4. Okay, we have 2 by 4. This is 2 by 4 chocolate bar, and cuts are from 0, 1 to 2, 1, 0, 1 to 2, 1, and 0, 3 to 2, 3. And its output is 2 to 4. See, where is 0, 1? 0, 1 will be uh, here. 2, 2, 1. 2, 1 be here. So we are going to make cut at this vertical line. Now we have 0, 3 to 2, 3. So 0, 3 is here, 2, 3 is here. So we'll make this cut. So output will be this area is 2, this area is 2, and this area is 4. 2 to 4. So now how we're going to break this down question. See, if you look at the constants, W and H are 100. So we can actually make the grid and do operation on it. Okay. So now I can make a grid of 100 by 100, and whatever inputs of breakage I have, somehow I'll store it somewhere and will try to do process over it. So see, if I have this kind of chocolate bar, okay, and if I want to make this chocolate bar same as my grid, the way we make 2D vector, okay, in code, a 2D array. So I have to store my all stuff in that 2D vector. Now, last time when we started the problem, my 0 comma 0 was here and W comma H was here. But when I'll convert this chocolate bar into grid, my 0 comma 0 element will be here and W minus 1 comma H minus 1 element will be here. So what first thing I'll need to do is to change axis. Okay, my axis will change. Now if you see, I have two elements but three edges. Okay, I can make cut here, here, and here. Same. If you look vertical, I have one, two, three, four. Four elements in my one row. But how many horizontal cuts I can do? Sorry, vertical cuts. One, two, three, four, five. One extra. Okay. So if my 0 comma 0 element is here, but when I have to cut down, okay, I need to break 0 comma 0 will be this point. So first thing is, whatever this element is, okay, like not element, the point, okay, whatever index I and j of this point, a box of if this box have I and j for I and j indexes, so this point, okay, left top point will have I and j coordinates. Okay, so see here what I can do. If I have a cut from this point to this point, okay, I will save this edge from this point to this point and another edge from this point to this point. Okay, now how can I do it? So this is of size n, this is of size m. So what I can do, I can make another horizontal vector, okay, of size n plus 1, because this is n plus 1, 0, 1, 2. Okay, I'll require 3, its size of 2, but I'll require 3 points to store horizontal lines. So h of n plus 1, it will be a set, okay, and this set will contain a pair of edges or breakpoints. So here it will be like this is point 1, it is from 1 to, no, sorry, here it will be h of 1, Okay, and in this set it will be from 0 to 1 and 1 to 2. So it will have 0 to 1 and 1 to 2 in it. Okay, for this case, same with vertical. Vertical will be of size m plus 1 and it will contain same set pair of, okay, it will be a set of pairs of breakpoints. Now, now what things I have? Okay, first thing is I have grid. Okay, where every uh, ijth element shows a chocolate bars piece. Okay, it's a single piece of chocolate bar. Then another thing is I have horizontal and vertical arrays which contain set of all pairs of breakpoints in that line. Okay, now anything else do I have? No. See, now I have a single piece. Okay, this is single piece of chocolate and I am here at I comma j point. From this, what I know, this point is I comma j. Okay, we earlier saw, see here I told you that if this is I comma jth index of 2D array, this point is I comma j. Okay, now this point will be I plus 1 comma j. Okay, this will be I comma j plus 1 and this will be I plus 1 j plus 1. Now if I am at this point and I need to go here, okay, like I want to check can I go to the right. So for right, what I can do, I have to check does a vertical line exist here. So you can see here the point is j plus 1. So I have to check in v of j plus 1. Okay, v of j plus will be a set. Okay, where I have to find which pair, I to I plus 1. Does I to I plus 1 exist? If it exists, what does it mean? It means that I have a wall here, like a breakpoint. I can't go to the right. Same with left, I have to check for v of j dot find and same I comma I plus 1. For I comma I plus 1, I have to check. When it comes to the up, for up, I have to check for I. Okay, it will be a horizontal I, and in this I have to find j and j plus 1. Okay, same uh, h of I plus 1 dot find j and j plus 1. This is for when I'm going down. Okay, these will be the four conditions. And how we'll do? We'll do BFS or DFS. Okay, anything will be work. And see, if I have this box, not a box, chocolate. Okay, and I have a break like this, breakpoint here, another breakpoint here, and another breakpoint here. So when I start a BFS or DFS, I'll visit this part, then this part, but I, I can't go here. Okay, then this part, but I can't go here, neither here nor here. Okay, so from this, how many I have visited? One, 2, 3, 4, 5, 6. 6. So I'll get one area which is 6. I'll put it in a vector. Okay, then if I start from here, I'll visit all these things again 6. From here, 1, 2, 3, 4, 5, 6, 7, 8. So it will be 8. After that, what I can do? I can just sort this vector and print it out. So I have already coded it. Okay, I'll just explain the solution. See, so first the input is n comma m and the queries. Where what are the queries? Queries are the how many breakage are there from a point to another point. Okay, so I made a vector of set of pair. Okay, to store horizontal cuts and vertical cuts. Okay, so I'll take a starting x-axis, starting y-axis, y point, ending x and y point. Okay, and if x points aren't equal, okay, if x points aren't equal, then y is going to change, and if y is going to change, then it's a vertical line. So what I did, from I started from s of x and less than e of x, and I added that vertical breaks are at the point e of y and ey, and I inserted every consecutive break from I and I plus 1. After that, it will be I plus 1, I plus 2. So I'll store every single edge, okay, of a piece where we are going to break. In else case, we'll store it in horizontal of E of x, ex, and insert every pair. Now my count is 0. What's count is actually? Count is going to count the pieces in while we are doing BFS. Okay, here I did BFS. This is vector of long uns. Okay, we are for whenever we are coming out from a BFS, we are going to store the count. Okay, in the answer, and at last we'll sort this answer vector and print it out. This is 2D vector to mark the visited points. Okay, now this is check function. It's just check that are we inbound or out of bound of the chocolate bar. Same like we are going out of grid or not. Okay, now this is a main function. Okay, this f function is actually doing the BFS. Okay, see, now for all points, if those points aren't visited, okay, if that bar, that piece of bar is not visited, what does it mean? That currently it's not part of any chocolate bar partition. Okay, we made such a partition, and if this piece isn't visited, it means that currently it doesn't belong to any partition. So we'll start BFS from it. We'll set count to 0, then we'll start BFS, and whatever count is, we'll push it into answer array. After that, we'll sort the answer array and we'll print it out. Now, what we have to think about that how we are going to implement this function. Okay. So in this function, what we did, now I have a starting point x comma y. Okay. I visited it. Then there's a queue of pair because we are doing BFS. We'll need a queue. Okay. In queue, what I did, I pushed that element, that pair of index x comma y. So While Q is not empty, I'll take that point, okay? And Cx and Cy are current x and y, okay? Whatever we are getting from the Q or first element, its x point will be Cx and Cy will be the y point, okay? Now, I'll increase the count by 1 because I visited this piece of chocolate bar, okay? Now, can go to right, can I go to right? If I want to go to right, what will be my new points? It will be x will be the Cx, but y will be, sorry, y will be Cy plus 1, okay? Now, I'll check that going to right, is it inbound or not? Will I go out of grid or not? If I'm not going out of grid, then what I have to do? I have to just find in the vertical set at y point, okay? Because I'm going to uh, here, when I was going to write, it was j plus 1, and here we updated, this is cy plus 1, okay? It's like j plus 1 which is in y, so v of y dot find x comma x plus 1. If that, okay, if that point is reaching to end, what does it mean? That there is no break there, okay? And the new xy points aren't visited, then I can go to that point and make it visited. So I push those indexes of xy in the queue and make it visit, okay? Same goes with the right, sorry, left. In left, we did cy minus 1, okay? But when we were checking for the left, okay? What we did? Okay, it's not actually left. Okay, I think in code I took indexes in different way. Okay, because if no, it's right, it's right. If I'm going to left, I have to check a vertical line. Okay, this is correct. Okay, this is same as what I explained. So when I'm going to left, I'll check a vertical with cy. Okay, here you can see I'm checking j. So here, what j is? The uh, original cy. Cy is the original point here, which is equal to j. So I check for v of cy dot find. If it's not there and we haven't visited that xy points yet, we can make it visit and push it in queue. With with going up, we have to check for horizontal in cx. Okay, horizontal was I. You can see horizontal was I, and sorry, when we are going we were going up the horizontal, I we were taking in consideration, while we were going down we were considering about h of I plus 1, okay? Because this is how we set our Cartesian and our grid with respect to each other. So here we'll find for h of c of hcx, and here for h of x, okay? And the BFS will go on. Whenever we'll reach to the that piece, we are going to make a count increment, and when all are visited in a partition, the BFS will get written and we'll push that into answer. After that, we'll sort it and we'll print it. So this was a 2000 rated problem, but it was easy. Just you wanted to somehow come up with how we are going to represent Cartesian plane. Okay, this was the main point was here. And after that, transitions. Okay, transitions to the right, left, up, and down. Whenever we are moving to right, left, up, or down, how we are going to check? Can we go to the right or not? These two were the main problems were there representing the Cartesian, because actually Cartesian starts from here, y-axis go here, x goes here. But what we had actually, our was starting from here, x was going here, and y was going here. Because this is how we are, this is we how store our matrix. Okay, so I think this was a very easy problem. I hope you got it. Thanks.